we have one of the former students from the first cohort of actually PhD students. And this is Adam. Now, Adam is actually going to do or talk about the oil drum experiment that is on the website. So I'd like a large round of applause, please, for Adam.
Thanks very much. Is that on? Yeah. Ladies and gentlemen, you've seen some fantastic demos so far. But the thing that I love most about science is the way that it makes you think differently about the world around you. And that's what I want to try and achieve today. So, take the air in this room, for example. It seems quite benign, but my task during the next few minutes is to try and show you it's anything but. So I have here a can, which I place a small amount of water inside. I'm going to put it on this burner. Don't forget it to stay, just for a few seconds. Now, I should say before we start this, please do try this at home. It's an excellent demonstration, but please don't burn yourselves. If you do burn yourselves, please don't sue me. I think that's, if I let that get a little bit hotter, very nearly ready. And what we're doing here is we're trying to boil the water inside to produce as much steam as possible. Now, hopefully, as I take this off, I'm going to turn it upside down and place it in the cold water, and we'll see what happens. We get one crushed can. So, why did that happen? Well, the air is made up of billions and billions of tiny little molecules, and these are all whizzing around, crashing into things. And when they hit into things, they impart a force. So this can is surrounded by a sea of atmosphere, which is that coming? Yeah. There we go. This can is surrounded by a sea of atmosphere, all these little molecules hitting into it. And they're creating forces on the outside trying to crush it. But it also has air inside, and that's banging into the internal walls, and that creates an opposing force. And because these two bodies have the same air pressure, they both provide the same force, and they balance each other out. Now, when we heat the can, we boil the water inside producing steam, and that forces the air out. Now, because the steam is at the same pressure as the air, it does the same job of resisting the atmospheric pressure. However, when we turn it upside down and place it in the water, two things happen. Firstly, we form a seal, and that stops any of the air from the outside getting in. But secondly, we cool the steam, turning it back into liquid water. So now there's no air pressure inside to resist the crushing force of the atmosphere, and we get a crushed can. Now, I'm sure many of you might have expected this to happen, but I'm guessing from the action of a few, that it might have been a bit more violent than you might have thought. Now, there's a reason for this. It turns out these air molecules move at incredible speeds, as fast as sound even. That's 740 miles per hour. Now, that's they're moving at 7%. Yeah, they're moving at incredible speed, 740 miles per hour. But when you think about it, it kind of makes sense that they should be moving that fast. Because all sound is the movement of these little molecules anyway. Now, yeah, so, when you, yeah, there we go, I'll go around now. Well, it turns out that when you add up billions and billions of particles all moving around at 700 miles an hour, it's an incredible amount of energy. There's easily enough energy for it to knock you clean off your feet. But that doesn't happen. And the question is why? That's because these particles are all moving in random directions. So on average, you have the same number of molecules hitting you from one side as the other. So they kind of balance out. But sometimes these become unbalanced. And we see this phenomenon in our day-to-day life, and we call it wind. Now, wind can be pretty powerful, as you might know. Now, this is a picture of Hurricane D, which is one of the most intense storms ever recorded, where winds ranged at over 140 miles per hour. It cost 45 lives and caused over $16 billion worth of damage. This is what happens when you have an imbalance of 10%. That's 10% more molecules hitting from one side than the other, causes this level of destruction. So it's no wonder the air is able to crush our tiny little can. But this got me thinking, if this is 10% of the power of the atmosphere, then surely we can get it to do more than just crush this tiny little can. Well, I thought we'd try something a bit bigger. So I thought we'd try something like this. So, this, you might imagine, is an oil drum. But being a conscientious science communicator, I thought it might be wise if I tried this out first. So I'm now going to show you a video of what happened when I tried it out. And hopefully this will explain to you why I'm not now doing it on the stage in front of you. This is the video. So as you can see here, we've heated up the barrel. There's a small amount of water in it. And that's producing lots of steam. We now take it off, seal it up, and the next job is to put it in the paddling pool to cool it down. There's a few issues with it floating around, so we just use these bricks in order to weight it down, to stop it going anywhere. Now, I'm going to pause the video there. Now, I tried this about 10 times. Nothing had happened at all. And I want you, as you watch the close-up video, which we're going to go to next, I want you just to realise that I'm sitting about 3 feet away with nothing but a tiny little camera in front of my face. Absolutely no idea what's about to happen next. There's what it is. Now, this will take me back to the place behind the pressure pump, the building next to us is over there. And you can see just in the top left-hand corner where it's just starting to go. 3 feet away, ladies and gentlemen. It's the loudest sound I have ever heard. The shockwave coming off of it shook the entire chemistry building. Simon, who's sitting at his desk, felt his desk shake, heard the noise, thought, 1, Adam's dead, 2, I was back.
Give a wake up.
Okay, rushing out to see what happened. This is the barrel in question. You can see just the level of destruction it caused. Those tiny little air molecules moving around cause these two lumps of metal to come completely together. But there's more. I thought, if going from something this size to this size caused that much destruction, was that much more violent, what happens if you go bigger? Well, I had a look around and I found something for you. And this is, the next video is of a train oil freight. And if you can see in it, well, I'll show you the video, let's watch yourself. That, ladies and gentlemen, is the power of the atmosphere. That is what is banging into you every single day of your lives. Thank you very much for listening.
Thank you, Adam. You can see there we kind of had a bit of a laissez-faire attitude to health and safety before tonight, which is why we've had to kind of remove some things. Actually, it wasn't just deafening, there was a risk of, well, death. Anyone with a heart complaint, probably the first 3 rows might have been wiped out. So we thought, but luckily we actually tried it. We weren't going to do the dress rehearsal either, it would have been live or dead here. But,